The purpose of fractionation or distillation column in an oil refinery is to process crude oil into multiple useful hydrocarbon products. Distillation is a process in which a liquid or vapor mixture of two or more substances is separated into its component fractions. This is typically by application and removal of heat. Hydrocarbons are typically given names by the number of carbon atoms in one molecule of that hydrocarbon. It is often referred to by the letter C, followed by a number. For example, C1, C2, C3 and etc. In addition to that, groups of hydrocarbons are commonly given names such as kerosene or diesel. These names are actually groups of different hydrocarbons. For example, kerosene contains hydrocarbons C12 to C15. And diesel contains hydrocarbons C15 to C20. When crude oil is distilled, the initial process will separate it into groups of hydrocarbons instead of individual hydrocarbons. Each group of hydrocarbons boils between different range of temperatures. These range of temperatures are also known as cut points. Crude oil is initially heated to temperature of typically 175 degrees Celsius using a heater. Crude oil then enters the fractionation columns. In the column, the crude oil flashes to vapor due to drop in pressure when entering the column. The vapor rises up the column. As the vapor rises up the column, it is cooled, condensed and turns back into liquid. The liquid will be removed at the respective height of the column. For example, naphtha is removed near the top and diesel is removed near the bottom of the column. The fractionation process is performed with a number of trays in the column. There are different designs for the trays. One of the common type is the bubble cap tray. Each tray is fed with liquid from the tray above it. The liquid flows through the downcomer of the upper tray onto the tray below. The liquid spreads out on the lower tray until the level is high enough to flow over the weir and through its own downcomer to the next tray below. At the same time, the vapor rises up the column through the bubble caps in the trays. The vapor is made to bubble through the liquid as it passes through each tray. The objective is to establish maximum contact between the vapor and liquid. The maximum contact in turn produces efficient distillation. A fractionation column consists of three zones, which are the flash zone, stripping zone and rectification zone. Feed from the heater enters the column at the flash zone. A large part of the feed flashes and flows up the column. This is called initial vapors. The remaining liquids flow to the bottom of the column. These liquids are called residue. The flash zone only provide rough separation of liquid and vapors. In other words, some vapors remain in the residue crude, some liquid remain in the initial vapors. The rectification zone is above the flash zone. The purpose is to remove further the carried over liquid from the initial vapors. This is done by a process of condensation enrichment process by cooling using condenser and reflux system. The refined product will be extracted at the respective column height. The stripping zone is below the flash zone. The purpose is to remove further the carried over gas from the residue crude. This is done by further heating. The heating is typically achieved using reboiler or introducing high temperature steam. The bottom product is taken off from the bottom of the column.